Hello everyone, good morning. So welcome to our data structures and algorithms session 2. This is session 1. In the yesterday session we discussed about all this, like what exactly is the data structure, okay, what is an algorithm, and what are the real-time scenarios where we will use all these data structures. Okay, so all those things we have seen in the yesterday session, and in our today's session I'm going to discuss about the time complexity and space complexity. See, there is much, so we need to discuss about this time and space complexities that we will see it in the further sessions. But today I'm just giving you a basic idea on this time and space complexity. Okay, any new students today? Okay, fine. So hi, to the new students, right? You'll get the backup video. Okay, yesterday session video will be sent to your registered mail ID. Please check your spam also. Sometimes this video links, whatever they are sending no through mail, that doesn't come into inbox. Sometimes it will goes to spam. Please check your spam also sometime. Okay. So all the big backup videos will be sent to your registered mail IDs, and my team will make a call to you people with your registered mobile number. Got it? So this is the second demo session. Okay. So in this demo session, that what we are going to discuss, everything I'll explain it to you. Okay, fine. So in session 1 yesterday, what we discussed in real time in our day-to-day life itself, we use so many data structures. So isn't it or not? Yes or no? Like, yesterday I said a plate stacker, you can take it. Okay, a cookies box, you can take it. Those are all examples for LIFO strategy, last in first out strategy, isn't it? Because whichever the cookie is inserted last will be pick up first. Yes or no? In the same way, the plate stacker also, whichever the plate was inserted last will be pick up first. Okay, last in first out strategy, that is nothing but a stacker. Okay, so coming to the banks, we'll go to the banks or we'll go to some other places to buy something, or vaccination drives, whatever it is, there we will form a queue. Got it? So that makes, queue is nothing but what which will follows a strategy known as FIFO, first in first out strategy. Got it? So coming to the Google Maps, so Google Maps, in the sense, it is using the what you can say, this graphs concept. Yes or no? So it will use as the graphs concept. Got it? Next one is what? Here we have a file explorer. How Google Maps uses the graphs concept, all the vertices are nothing but cities here. Yes or no? Every vertex is connected to another vertex. Okay, isn't it or not? Through the edges. Got it or not? Okay, that will be implemented using this graphs concept. Coming to the file explorer, you'll be opening the drives or desktop or this in this PC, right? So we'll be opening the file explorer, right, which will follows the tree like structure. Got it or not? Okay, then our music players are the best examples for all of the linked list, which will play only in a forward direction or in both backward and forward directional, bi-directional, or in a repeat mode. Isn't it or not? Repeat mode is an example for circular linked list. Got it? So these are all, see, in our day-to-day regular life itself, we are using different type of data structures without knowing ourselves also. Got it or not? Okay, so today I'll just give you an introduction about these data structures and algorithms, and what exactly is the time and space complexity, why we require this time and space complexity. Okay, how to represent that time and space complexity, everything we will discuss it for today's session. Okay, so actually there is a problem with my internet today. It is again reconnected. If at all, if connection gets disconnected, please stay, I'll connect with my mobile. Got it? I'm just intimating you before. Okay.
Okay.
Yeah, fine. So first thing, so let's concentrate. So here programming, yes or no? So what exactly is the programming? So programming is nothing but I will define like this. So data structures plus algorithms. Data structures plus algorithms, I will call it as a programming. Got it or not? Okay. One more minute. Give me 1 minute. Actually, in our, see, for the new students, right, I'll just give you an overview of how our course will be. Okay, this is a 3 months course. Okay, so the entire syllabus you will get it. I mean, I have my own framing of syllabus is there. Okay, that I'll send it to you. Today I will give you the links. You please log in into that particular Telegram and WhatsApp group so that you will get my own syllabus copy. And I mean, in our website also that syllabus copy is there, but my own whatever the topics that what I'm going to cover in my course, right, I have mentioned everything. Got it? That I mean, you will get it to your mail IDs, registered mail IDs. Got it? And one more thing is, this is 3 months course, I said, right? First 2 months of a course, right, I'll discuss all the topics that let me just show you. So but in detail the syllabus you'll get it to your registered mail IDs. Okay, so first I'll cover the basics of this core Java. Got it? Like whatever is important to implement these data structures. Okay, so the basic knowledge of core Java is enough to learn these data structures and algorithms. You don't require the complete knowledge of entire core Java. Okay, like if you have an idea on arrays, methods, this is enough to what you can say, understand these data structures and algorithms. Okay, so here in these data structures I'm going to cover the stacks, queues, circular queues, and all I'm implementing in both array and linked representation. Got it? And double-ended queues, circular queues, linked list, priority queues, single doubly circular and sorted linked list, trees, graphs. Got it or not? Understand? So these are all the topics that we are going to cover, like searchings, okay, heaps, sorting techniques, recursion, hashing techniques are there in graphs also, BFS and DFS, tries, AVL trees. Okay, these are all just headings I have provided, but someone asked yesterday, right, they need a clear subtopics under that each and every topic. That's why we are preparing that, and we'll send it today by end of the day. Okay, that entire syllabus copy, and this will take 2 months of time to complete this entire syllabus along with the data structures and algorithms topic. Okay, and next thing is we are going to solve lead code problems. Got it or not? Lead code and hacker rank problems. I have listed some 100 to 150 lead code problems. I may cover 200 also, but I'm not giving an assurance. Got it? So maximum 100 to 150 programs will be covered in all these data structures and algorithms using Java competitive coding. I mean, take hacker rank or lead code or anything. I'll provide that entire list to you. Got it? Which will be asking in most of the interviews very frequently. Got it? All those questions will be covered in the next 1 month of time. Got it? Entire 1 month will focus on that. And that's what I'm telling you. I may cover more than 150 also. If I tell like I will cover 300 or 400 like that, if I don't do it, see, it impacts on my feedback, isn't it or not? That's what I'm telling you. I surely I mean, cover 100 to 150 programs for sure, but maybe more than that also. I have a plan, but I don't tell you now. Okay, maybe I may cover more than that also, but these are mandatory 100 to 150 programs we are going to cover in our course, which is very frequently asking in interviews. Got it or not? Okay, fine. And in our website, right, if you see our website, no, so these are all the, yesterday also I said the same thing to the students whoever joined. Okay, so these pattern printing programs and these arrays programs and these mathematical fundamentals of arrays programs and these matrices related programs and these fundamentals of mathematics programs, I am covering all these in my core Java class itself. I'm not bringing all these to data structures where these are the very basic programs. Got it or not? Understand? So these will be covered in my core Java class itself, but because in our website they have mentioned all these, that's why I will cover all these programs also in our course in the starting of the sessions itself. Got it or not? Along, say, excluding this, we are going to cover the lead code and hacker rank, other coding platforms programs, almost from 100 to 150 programs for sure, for sure. Okay, more than that means that is in my choice. Okay, so I may cover for sure, but I'm not telling you. Got it? Understand? So this is what, and this is what we discussed yesterday. The course fee is 7,000. Got it? Because see here, that's what, yeah, I cleared, right? I cleared, right, about the syllabus, about the course duration and all. It is 3 months course. 2 months we are going to cover the entire syllabus along with the programs. Please make a note of that. Not only theoretical part. Stack, when you are implementing in arrays and linked list, means you are going to write a array representation of stack program, and all, as well as linked representation of stack program. In the sense, in the same way, on each and every topic also, theoretical concept, algorithms. Okay, so that algorithms plays a vital role, because when you know the algorithm, you can implement these data structures and algorithms in any programming language, by using any of the programming language. No, data structures is not a language, it is a concept, right? We are going to implement this concept in any of the programming language. That is your choice. Understand or not? That is what the reason in my class specifically I am focusing on the algorithms. If you know the algorithm properly, then you can very easily implement that algorithm in any programming language, that whatever you wish. Got it or not? Understand? So this is what our course duration, course fee, and what we are going to cover in our entire course. Everything I have mentioned you clearly. If you have any more doubts still, you can please wait till end, so that I'll clarify all your doubts. Got it? Fine. So first I'll give you an introduction about this data structures and algorithms. Okay. So programming is nothing but what? Data structures plus algorithms. Okay. So what exactly is the meaning of this data structure? So data structure means what? It is nothing but it is a way of organizing the data so that it can be accessed and modified in an efficient way. Got it or not? 1 minute, students. Biswajit, it is 7,000 without videos. With videos, it is 10,000. The video access will be there for you for 6 months. Am I audible? Biswajit, is it clear? Got it? 1 minute. I'll just provide you 2 links. Okay, you can please join there so that you'll get all these details there. Okay, please join into this Telegram and WhatsApp group, and please watch out my videos also. These 2 are my core Java interview questions videos. Okay, next Saturday also we are going to take a free workshop on Java features, new features and garbage collection and all. Okay, please attend for that. So join into the Telegram and WhatsApp group so that you will get all the updates, even the syllabus copy of data structures and algorithms, lead code problems, that what we are going to cover, everything you'll get it. Okay. Yes, after completion of the course, okay, 3 months it will take, right? After completion of the course, another 6 months, the accessibility is there for you people. After completion of the course, yes. The course duration is 3 months. Every day the classes will be from Monday to Saturday. Okay, Monday to Saturday we have sessions, and from 8 o'clock to till 9:30 we have a session. Every day 1.5 hours. First 1 hour 15 minutes will be taking a session, and last 15 minutes we are giving it as a doubts session. That means if you have any doubts, okay, we'll clarify all your doubts. Okay, so otherwise sometimes it may, the concept is that the lengthy concept compulsory we should continue, that concept will continue till 9:30. Got it or not? Every day the session is 8 to 9:30. So demos will be connected for 5 days. This is the second demo session we have. So today is Thursday, right? Friday. And next we have same demo sessions on Monday and Tuesday. By Tuesday, the demo sessions gets ended. Only the people who have registered for this course, okay, they'll only get a new link to their registered mail ID, and you can log in with that particular registered mail ID till the end of the course. Okay, sorry, with that Zoom link till the end of the course. Got it? And one more thing is after demo sessions gets completed, right? We are going to provide a WhatsApp group link to you. Separate group will be created. There, all our admins, everyone is there. Okay, and you can get entire notes also through WhatsApp, or else we will upload the same notes in website also. Backup videos for everyday session will be uploaded by next day, middle noon, mid of the noon, before mid of the noon, you will get it. Got it? Understand? And the notes will be shared along within the website as well as in the WhatsApp group also, so that you can keep in touch, because WhatsApp is very handy for us, right? So that's why we are going to create a WhatsApp group, and there we will share the entire notes for you people. Okay, every Saturday, second Saturday and fourth Saturday, we are going to give some assignments, right? So in that 2 weeks of sessions, that whatever we have done, right, so we are going to take some programs. Okay, we'll practice it. I'll give you everything. Yeah, please, Mahajan. So I'll give, say, every second Saturday and fourth Saturday, we are conducting the exams in the sense, not like, see, up to the 2 weeks, whatever the concepts that we have covered, right? On all those concepts, I'm going to provide you the programs that you have to provide the solutions for that. Okay, that is an interactive session. You can clarify your doubts also there. Okay, so I hope I have cleared all your doubts regarding the course and all. Okay, if you require more information about this, please contact our admin. At the end of the session, I'll provide my admin details to you. Okay, so first I'll start my session, so that I'll give an overview of these data structures, algorithms, time complexity and all. Okay, fine. So programming is nothing but data structures plus algorithms. What is a data structure? What is a data structure? So data structure, okay, is a particular way of organizing the data so that it can be accessed, okay, and modified in an efficient way. Okay, understand or not? What is a data structure? It is a way of organizing the data. We are going to store the data in a proper way, okay, so that it can be accessed and modified efficiently. Got it or not? Okay, fine. Algorithms and data structures are the most important building blocks of computer science. So these data structures and algorithms are the very important building blocks of a computer science. Say example, generally, if you want to say example, I want to write an algorithm. Got it or not? Simple. Algorithm is nothing but a step-by-step procedure to solve a particular problem. It is a well-defined computational procedure. Okay, so which is taking some set of values as inputs, and it will transforms them, and then it is providing the desired output based on the given input. Yes or no? Simply, how can you define an algorithm? It is nothing but a step-by-step procedure. Finite number of steps will be there, not infinite. Okay, finite number of steps will be there, and by using that, you are going to solve a particular problem. Got it? So one problem can have many solutions. One problem can have many algorithms. One algorithm can be implemented in many ways. Both ways are there. Yes or no? One problem can have many solutions, means you can write multiple algorithms, and one algorithm can have many implementations also. Both ways will be there. Got it? So now, what is an algorithm? So algorithm, how can you define an algorithm now? Tell me. So algorithm is a well-defined, see, computational procedure. Okay, so that takes what? It is taking a set of values as an input. Yes or no? It is taking set of values as inputs, and what it is going to do, and it is transforming them. That means what? It is performing some tasks on that. Okay, and transforms them into the desired output. Depends on the input that whatever we have provided, we are getting the desired output here. Okay, so generally we will write this algorithm in two ways. One in normal simple English, another one in pseudocode. Okay, so I will tell you those things also to you. Okay, so first thing, I'll tell you one more thing. So data structure is nothing but it is a particular way of you are organizing the data so that you can access it and you can modify it in a proper way. Got it? So algorithm means what? It is nothing but it is nothing but a procedure which is taking some inputs from us and it is transforming that inputs into our desired output. Got it? So anyone can write the algorithm. If you want to solve a particular problem, you are going to write the algorithm. That is okay. But writing the space and the time efficient algorithm plays a very important role in the software industry. Got it or not? So you have to write an algorithm where it should take the less time and less space. Okay, that type of algorithms plays an important role in the software industry. Got it or not? So then generally, if anyone asks how to analyze an algorithm, how to analyze the performance of an algorithm, there are two ways are there to analyze the performance of an algorithm. I'll tell you those. Okay, so writing the space and time efficient algorithm. Okay, writing the space and time efficient algorithm plays a very important role, a very vital role, okay, in software. Got it? Okay, how to write the space and time efficient algorithm? Very simple. So the analysis, the performance analysis of algorithm will be done in two ways. Okay, how to analyze the performance of an algorithm? Tell me how to analyze the performance of an algorithm. Okay, how to analyze the performance of an algorithm? Using what? The first thing is what? Time complexity. And second thing is space complexity. Okay, so the second thing is space complexity. Okay, fine. This is how you can analyze the performance of an algorithm. Okay, so I have defined, right? So what is a data structure? We know now. What is an algorithm? So writing algorithms, it doesn't make sense actually. Writing the space and time efficient algorithms is very, very important. So then how to analyze the performance of an algorithm, how to tell that whether this algorithm is good and this algorithm is bad, like that, how can you analyze it? The performance of that means by using this time and space complexity. Got it? Understand? Now the next one is algorithm. See here, I said now it is nothing but a finite number of steps to solve a particular problem. This is normal definition for the algorithm, isn't it or not? So an algorithm is nothing but a finite set of steps that you should follow to solve a problem. Got it or not? Am I going fast? An algorithm is a finite set of steps. That means what? There is an end for this algorithm. Finite number of steps, not infinite number of steps. Please make a note of that. Okay, that you should follow. Yes. Okay, Ritik, I'll go little slower. Okay, and I think I am correct. I'm perfectly going on. Okay, no problem. I'll go little slower. Okay, is everyone feeling okay, right? Comfortable, right? Is it good? Okay, fine, no problem. Thank you so much. So an algorithm is nothing but what? It is a finite number of steps, finite set of steps is there that you should follow to solve a particular problem. The problem can be anything. It can be anything. If you want to solve a particular problem, you're going to follow some steps. Okay, like say example, I want to prepare a tea. I'll follow some steps, right? That is an algorithm. Understand or not? I want to search for a particular element in an array, then I will follow some steps. Either I'll follow a linear search or binary search. For that, first of all, I'll write this is how I should take a first element. I should compare the search element with each and every element present in an array till it reaches to the end of the array. That is some steps you are following, right? That we will call it as an algorithm. Okay, now fine. So next, we can write this algorithm in two ways. Okay, so we can write an algorithm in two ways. Okay, so in two ways you can write it. Okay, either in normal English, either in simple English also you can write. Okay, in simple English you can write, and in pseudo code. Okay, I'll show it to you. That both I'll show it to you. Okay, and in pseudocode. Got it. So these are the two ways to write an algorithm. So for one in normal simple English and another one in pseudocode. Got it. So now, so simple English in the sense what? Say example, I want to write a swap algorithm. Okay, I want to write a swap algorithm. Tell me, swapping means what? Interchanging, right? So you have two numbers, A10 and B20. You want to swap those two. That means B value 20 should come to A and A value 10 should goes to B. Isn't it or not? Generally, how to write that algorithm? In step 1. Okay, input first number into what? A variable. Second step. Okay, so input second number into B. Okay, third step, assign. You can use a temporary variable, or without using temporary variable also you can do it. That is your choice. Okay, you can take a temporary variable or third variable, assign temp is equals to A. Okay, then fourth step is what? Assign. Okay, A is equals to B. Fifth step, assign B is equals to temp. Yes or no? First A value, I am moving to temporary variable. Once I move this A value to temporary variable, I am moving this B value to, I am assigning this B value to A variable. Then temporary variable consists of A value, no, that I am assigning to B. In this way, I will do a swapping process and finally I will end it. This is a normal simple English that I am going to use it for writing an algorithm. Okay, so coming to the pseudocode now. Okay, so how to write the pseudocode now? I'll write it here. Okay, I'll write it here, pseudocode. So very simple. You can write it. See, pseudocode is nothing but what? First thing. Okay, what is nothing but a pseudocode, madam? Is this a syntax? No. Yeah, please. Ritik, actually, here what I'm doing is, I'm doing like this, Ritik, I'll show it to you. A10 and B20, right? I am taking another temporary variable, temp is equals to. Okay, the meaning of this one is, I'll tell you, temp is equals to A, no. That means A is what? This is an assignment operator where it is storing the right hand side value to the left hand side variable. Okay, A is 10, right? This 10 is assigned to temp variable. So now temp consists of 10. Okay, and after that B value 20 is there, right? This B value 20 you are assigning to A variable. Okay, now A consists of 20. Okay, A consists of 20. That means in the place of this 10, you are storing 20. Okay, fine. Next, B is equals to temp. This temp value 10, you are assigning to B. Okay, so that temp value 10, you are assigning to B. That means what? B consists of what? So earlier B consists of 20, right? Now the 20 will be erased, and in the place of that it will store 10. Okay. Now when you see earlier A is 10 and B is 20. Now it is A is 20 and B is 10. This is how you will do the swapping process. Got it or not? Are you clear, Ritik? Fine. Yeah. So now, next, pseudocode. So what is a pseudocode? Is this a syntax that we are following? No, it is an informal program description, okay, which does not contain any program syntax. It does not contain any programming language or program code syntax. Got it or not? Informal program description that you can write it in your own way. You no need to follow any of the syntax here. Whereas if you go for C or Java or Python, you should compulsory follow the syntax. Okay. Pseudocode is not like that. It is an informal, okay. So program description, okay, that does not contain any program code syntax. Okay, you know that yesterday I said, right, the grammar of a particular programming language, we can call it as a syntax. Yes or no? Every programming language will have a grammar. That grammar we are calling it as what? Syntax. Got it? So it is an informal program description, okay, that does not contain any program code syntax. Informal program description that does not contain any program code syntax. Got it? So now let's see here, swap of, I'll be writing like this. See here, it is not a syntax. Please make a note of that. That you can, this is just an informal way of writing the code. Got it? So that you can write it in your own way. That is your wish. Got it? I wrote like this, swap of A comma B. Okay, so here I'll be writing like this, temp A. I'll write like this. Okay, in pseudocode you will be writing like this. Assignment you will do it like this, ma. Assignment you will do it like this. Okay, then like this. Madam, do we need to write like this only? That's what I'm telling you. That is your choice. That is your choice. This is not related to any of the programming language code syntax. That is your choice. You may write like this also. Temp is equals to A is equals to B is equals to temp. Like this also you can write. Okay. So this is how you will write an algorithm in two ways. One in simple English, another one in pseudocode. Got it or not? Okay. Am I clear up to here? Whatever I have given an explanation about an algorithm, okay, data structure, writing the time and space efficient algorithm plays a very important role. How to analyze the performance of an algorithm using the time and space complexity. Yes or no? So algorithm is nothing but what? It is a finite number of steps that you should follow to solve a particular problem. Okay, so we can write the algorithm in two ways, one in simple English and another one in the pseudocode. That is your wish. You can choose anyone, whatever you want. Generally in data structures, right, you are following this pseudocode only for writing the algorithm. You don't follow this normal English for writing the algorithm in data structures. Yes or no? We are going to write the stack, push algorithm, pop algorithm, peak algorithm, okay, display algorithm, insertion. If you come to the queues, right, insert algorithm, delete algorithm, all these things you are going to write using this pseudocode way only. Okay, we are going to write the algorithms using this pseudocode only. We are not going to write algorithms using in simple English. That is just for our understandability purpose. Okay, generally we write the algorithm in this format only. Please make a note of that. That's why I have mentioned here. Okay, fine. Next. So next thing is what? How to analyze the algorithm. That's what I said now. How you are going to analyze the algorithm? I'll tell you. Okay. So there are two ways to two important factors will be there to analyze the algorithm. Those are what? Time and space complexity. Yes or no? Fine. Now, the first thing is what? Time complexity. Okay, so the first thing is time complexity. Time complexity means what actually? Yes, how much time an algorithm takes to produce the desired output. Yes or no? How much time an algorithm takes to produce the output, or else a desired output or output, whatever it is. Okay, desired output. How much time an algorithm takes to produce the desired output. That is nothing but a time complexity. So next one is what? Space complexity. Okay, space complexity. So space complexity means what? How much memory space an algorithm consumes to produce the desired output. Yes or no? How much memory space an algorithm consumes to produce the desired output. Got it or not? Understand? Now, this time complexity is there, no? How much time an algorithm is taking to produce the desired output, how much memory space an algorithm consumes to produce the desired output. This is nothing but a time and space complexity. Okay, but this time complexity of an algorithm depends on various factors. Like, it depends on the machine architecture, it depends on the processor, it depends on the execution type, it depends on the memory access time, it depends on the given input. Okay, so time complexity will be dependent on so many factors. Okay, various factors, but here in our case, right, we are just considering our input only. Got it or not? We are not considering the other factors like machine architecture, processor, execution type, memory access, everything we are not going to consider. We are going to consider the given input only. So depends on our given input, right? Okay, so depends on our given input, how much time and space it is that algorithm is going to occupy. That is what I'm going to tell you. Understand or not? So time and space complexity is, time complexity of an algorithm depends on various factors. Okay, depends on various factors. Okay, what are those? Machine architecture, yes or no? And processor, which processor you are using, execution type, how you are executing. Okay, like this, so many, memory access time. Okay, so like given input also, but we are not considering etc etc. Got it? We are not considering all these things into consideration. Okay, so for calculating the time and space complexity, in our case, I'm talking about, in our case, we are going to use the what you can say, only the given input I am considering here. Okay, I'm using only given input. Got it or not? This time and space complexity is a very lengthy topic, and so many things are here to discuss about this time and space complexity. Got it? So, but before going to discuss about all these things, I'm just giving you an overview of this. Got it or not? Okay, so let me just explain the time and space complexity now. But before going to explain, I'll take an algorithm. For that algorithm, how much time and space complexity it is occupying, I will tell you now. Got it or not? So there are so many, worldwide, so many languages are there. Got it or not? So to represent a time and space complexity of a particular algorithm, we require a common notation. Yes or no? We require a common notation to represent the time and space complexity of an algorithm. Understand or not? We should not consider only ours, our English. So many languages are there. So many people are using the same thing. Everyone is considering the performance of an algorithm, right? But we all require a common notation that is used for representing the time and space complexity of an algorithm. That is nothing but asymptotic notation, big O asymptotic notation. That notation we will call it as asymptotic notation, which we are going to use it for representing the time and space complexity of an algorithm. Got it? So big O is nothing but it is a language and a metric we use to describe the efficiency of an algorithm. Okay, we used to describe the efficiency of an algorithm. Big O notation, we can call it as asymptotic notation. We have big omega, we have big theta, everything is there. We will discuss more about that. That's what I tell you, I said, so we'll discuss more about that in the further sessions, but here I'm giving you a just a overview on this. Understand or not? See, now here I am in India, some people will be there in Japan, some people will be there in... Yes, Swagat, I am typing something here. Yes, I am writing, no, everything on the screen. Are you not able to see? 1 minute. Okay, fine. No problem. Yeah. See, will be here and some other person will be there in some other country. Everyone is worldwide, worldwide, everywhere, everyone is working on this performance of an algorithm, right? If I will follow one notation, some other person will follow one notation. It doesn't make sense, right? Isn't it or not? So that's why what the scientist has decided, okay, if you want to represent the performance of an algorithm in time and space complexities, see, we will use a common notation for everyone. So if anyone wants to represent, go for that notation, you represent it. Like that, they decided that is nothing but big O, big omega, big theta, asymptotic notations. Got it not? So this is a big O is the language and the metric. Okay, language and the metric we use to describe. Understand or not? What we are going to provide here, we use to describe the efficiency of an algorithm. We use to describe the efficiency of an algorithm. Got it or not? Okay, big O notation, we are going to use it. Understand? Is it clear or not? So to measure the performance of an algorithm, so generally this big O notation will be used. Okay, understand or not? So algorithm can perform differently based on the condition. Yes or no? If say example, you have taken one algorithm, that algorithm can perform differently based on the conditions that what we have provided in that algorithm. Okay, so we used to measure the performance of an algorithm in 3 cases. One is the best case, another one is the average case, and next one is the worst case. Got it or not? Understand? We have 3 scenarios, ma. Got my point or not? So these algorithms can perform differently based on the condition that what we have provided in that algorithm. Okay, so what are those cases? 3 scenarios are there when we are measuring the performance of an algorithm. Okay, 3 scenarios. What are those? Best case, okay, average case, and worst case. Best case, oh, something gone, right? Okay, okay, done. So best case, worst case, and average case, or average case and worst case. Okay, that means what? Generally, say example, you are solving a particular algorithm. Okay, in the best case it will take some 5 seconds of time to execute. In the average case it is taking some 30 to 40 seconds of time. In the worst case, if it is taking 1 minute of time to execute, like that. Okay, 3 scenarios will be there. Got it or not? This is the common asymptotic notation that we are going to use it to describe the efficiency of an algorithm, either in time complexity and in space complexity. Got it or not? Okay. So we will discuss more about the big omega and big theta notations in the further sessions. Got it? Here we have so many, I mean, in this big O notation, right, we are going to use different language metrics like O of one time complexity or space complexity, O of n, okay, then O of n square. When you will get this time and space complexities, O of 1, O of n square, okay, then O of log n. Got it or not? So log n. Okay, so O of log n time complexity or space complexity, and O of n cube also. Okay, cubic we can call it as quadratic, we can call it as linear, we can call it as constant, we can call it as logarithmic, we can call it as and big O notation like exponential we can call with so 2 to the power of n. Okay, so O of 2 to the power of n, like this. So many so many ways we are going to represent the time and space complexities. That entire thing I'll explain it to you now. Is it clear? Yes, up to here, is it clear? Fine. Now I'll take a simple example. And I'll tell you how you are going to find out the time and space complexity. Just a simple example. Take this swapping only. Okay, this one. This swapping is there, no? This swapping you can take it. Okay. Let us assume like, okay, every statement here occupies 1 unit of time. Okay, every statement occupies 1 unit of time, and every variable occupies 1 unit of memory. Let us consider like that. Let's assume like that. I'm telling you. Understand my point or not? Okay, here we are considering every statement as 1 unit of time and every variable as 1 unit of memory it will occupies. Got it? Now you calculate the time and space complexity. Okay, so time complexity I'm calculating here. For what? For swap algorithm. Okay, for swap algorithm I'm calculating the time complexity. Okay, so total time taken, how can I calculate? T of x you can provide. T of x is equals to, okay, this first line is there, no? Temp is equals to A is there, no? This one. So this one occupies 1 unit of time. This one occupies what? 1 unit of time. Understand or not? And next one is there, na? A is equals to B. A arrow B or A is equals to B is there, right? If it is occupying 1 unit of time, that's what I said, no? Let us assume like every statement occupies 1 unit of time. Okay, so temp is equals to A, occupies 1 unit of time, A is equals to B, occupies 1 unit of time, and B is equals to temp also occupies 1 unit of time. Got it or not? So total how much? 3. Total how much? What? 3. So that means T of x is equals to 3, which is a constant. Yes or no? Which is a constant. So this is known as the time complexity of swap algorithm is a constant time algorithm. Okay, it is taking a constant time. Understand my point or not? For any value of A and B, it is taking a constant time. You take A value as 10, B value as 20. You take A value as 100, B value as 200. You take A value as 1000 and B value as 2000. Okay, 1 minute. Give me just 1 minute. Okay, yeah. So for any value of A and B, if A is 10, AB are 10, 20, or if AB are 100, 200, or if AB are 1000, 2000, or if AB are 10,000, 20,000, whatever may be the value of A and B, it is occupying the same amount of time, right? That's why this is known as a constant time algorithm. It is known as what? A constant, okay, constant time algorithm. Okay, so that means what? So the time complexity of a constant time algorithm, how can you represent the time complexity of this swap algorithm is big O of 1. You'll represent 1. This O of 1 is nothing but which will represents the constant time algorithm, constant time. Understand my point or not? Is it clear? This is how you will calculate the time complexity. So now what? So space complexity. Okay, so you should calculate the space now. 1 minute. Okay, space complexity for swap algorithm. Okay, fine. Now, space complexity means what? Every variable occupies 1 unit of memory, I said now. Every variable occupies 1 unit of memory. So, space complexity S of x is equals to, how many variables are there? A is one variable, B is one variable, temp is one variable, isn't it? So, 1 plus, for A, 1 unit of memory. For B, 1 unit of memory. For temp, 1 unit of memory. Total how much? 3. Got it or not? That is what? A constant. So that's why S of x is equals to, S of x is equals to what? O of 1 only. Big O of 1 only. That means for any value, I mean, here in this swap algorithm, you are taking only 3 variables. That's it. So which is a constant, right? Always it occupies a constant space. Got my point or not? That's why the space complexity and the time complexity of a swap algorithm is constant time. Okay, O of 1 is the time and space complexity of a swap algorithm. Got it or not? So when you take only single for loop, okay. Okay, so when you take another 1 minute, don't yeah, please. So when you take another for loop, right, so if you are taking a for loop, you may get O of n time complexity. If you take nested for loops, got my point or not? Some situations will be there where you are using the nested for loops. Understand or not? So when you are using nested for loops, you may get O of n square time complexity. O of n square. Got it? So if you want to find an element in a sorted array, by that time you will get what you can say logarithmic time complexity. Okay, that means what? You are taking one for loop inside another for loop. Okay, even if you take multiple for loops, separate multiple for loops, even if you take it in your program, it is taking O of n only the time complexity. Okay, so but if you use one for loop inside another for loop, that means nested loop, then quadratic time complexity, we can call it as O of n square. If you write one more for loop inside, O of n cube is the time complexity. Okay, so take the Fibonacci sequence or Fibonacci series, right? Double recursion, isn't it or not? So you are, by using the recursion, when you implement the Fibonacci series, right, which will takes a exponential time complexity. Got it or not? So like that, I'll tell you all those examples in the tomorrow session. Got it or not? Like we'll be taking a for loop, got it or not? So I'll take a for loop and I'll write a I'll just provide one program to you, one small code snippet to you. For that, you should tell the time and space complexity. Got it or not? Okay, so say example, if I take like this, let me show you. Okay, so like I'll take like this. 1 minute. Into product of Indian. Okay, I'm taking like this. Int I comma product is equals to 1. You can take it. Understand? Okay. You can take a prod also. That is your wish. Okay. Because the method name and the variable name both will be same now, you may get confused. That's why this is just for understanding purpose, not more than that. I1 you have taken, I less than or equals to n, and I plus plus you have taken. Got my point or not? Okay. So this is what. Okay. So here I'm writing prod is equals to prod into I, you can write it. Okay. So here you can write return prod. That's it. Okay. Now, can you tell the time and space complexity for this particular code snippet? Here we have now. Okay, here I'm just writing. I'll close it. Okay. So for this, I want a time and space complexity. So T of X. Okay. So T of X. How can you find out the time and space complexity for this? Have you said, Mohit? Yeah, I'll tell you. So here, time complexity. Let's take a time complexity for this. Got it. I'm just telling you a short forms. Short forms I'm telling you, students, please make a note of this. Okay. Say example, according to our logic, right? So every statement occupies 1 unit of time. Now, here, this first statement is there, right? Like int I comma prod 1, that will occupies 1 unit of time. Okay, now 1 unit of time that will occupy. So then next one is what? This for loop is there, right? Amma, tell me how many times this for loop is going to repeat? This for loop is going to repeat for n times. N times true. N times true. N plus 1th time fail. Yes or no? Actually, this loop, everyone will say like n times the loop gets repeated, but no, n plus 1th time it repeats. N times true, 1 time false. Yes or no? Say example, n is 10 ma. So 1 to 10 it will repeat. 11th time also it will go up, but it will fails. No. 11th time it will go up, but it will fails, right? So totally how many times that loop gets repeated? How many times the loop gets repeated? N plus 1 time. Understand or not? Okay, this loop will repeats for n plus 1 time. N times true, 1 time false. It will comes outside. But inside one statement is there, right? Prod is equals to prod into I. Ritik, very clear, Ritik, here. I have given n value as 10. Okay, n value I have given 10. So this loop is repeated for how many times? I1, I less than or equals to 10. First time comes inside true. 1 less than or equals to 10 true. Prod equals to prod into I, it will performs. Then again it goes up. I plus plus I2. 2 less than or equals to 10 true. Like that the loop gets repeated for how many times? 10 times. 10 times multiplication will be done. Yes. I plus plus I becomes 11. 11, I 11 now. 11 less than or equals to 10. 11 less than or equals to 10. False. It will comes outside. That means the loop is repeated for how many times? N times true, 1 time false. N times true, 1 time false. Yes or no? And inside this statement is there, right? Prod is equals to prod into I. Prod is equals to prod into I is there. No. So that is repeated for how many times? That is repeated for n times only. That is repeated for n times only, na? Because n plus 1th time it fails, no. 11 less than or equals to 10 false. It will comes outside, never executes this statement. This inside statement, prod is equals to prod into I, product is equals to product into I, will be performed for only how many times? N times only. And the written statement will occupy 1 unit of time. So total how much? 1 plus n plus 1 plus n plus 1. That means 2n plus 3. This is a polynomial expression, right? Yes or no? Got it or not? This is a polynomial expression. Okay, so this is a polynomial expression. So here we'll take the largest exponent, that is the degree of the polynomial expression as see the largest exponent. What is the largest exponent? That will becomes the degree of the polynomial expression, right? That we are taking it as a time complexity here. Yes or no? So largest exponent is what? N to the power of 1. Largest exponent is what? N to the power of 1. So that's why That's why T of X time complexity is O of N. You will take it. O of N is a time complexity for this. Okay. O of N is a time complexity for this. So what about the space complexity now? Tell me how many variables are here. N is one variable, 1 unit of memory. I is one variable, 1 unit of memory. Prod is one variable, 1 unit of memory. So total, how many variables we have? 3 only. So 1 plus 1 plus 1, that is 3, which is a constant. So the space complexity, how much it occupies? Constant space complexity, constant time. Understand or not? Constant space also. O of 1 is a space complexity. Time complexity is O of N. So depends on this N, right? Depends on the N, the loop gets repeated. That's what. Say example, if we have N 1000, O of N, isn't it or not? That's what I'm telling you. It will goes linear. Depends on the N value, the time complexity will grow. Got it or not? For that, we'll see the solutions for all those. Got it or not? So it depends. This time complexity of this algorithm depends on the N value. If N is 10, repeats for 10 times. If N is 1000 or 10,000 or 1 lakh, it will goes linearly, no? Isn't it or not? Yes or no? So for that purpose only we'll go for other things. Okay, we need to write the better solution for that. Got my point or not? Is it clear? Okay, so this is what I mean, I am just telling you how these time and space complexities will be represented by using these big O notations. When you will get O of 1, when you will get O of N, when you will get O of N square, when you will get O of log N, when you will get O of N cube, O of 2 to the power of N, all those things I'm explaining you. In these cases, you may get this time and space complexities. That's what I'm telling you here. We'll discuss how to resolve these problems also. Got it? And how efficiently we should write the algorithm, we'll think about it in our further sessions. Got it or not? But first of all, you should know how to use these big O notations, right? When to use these big O notations, right? So in these cases, we are going to use it. Understand? Got it, students? Space complexity is very simple, Meghraj. Here, how many variables that we are going to use it here? N is one variable, right? One unit of memory. I is one variable now, 1 unit of memory. Prod is one variable now, 1 unit of memory. So total how many? 3. 1 plus 1 plus 1, 3. So for any N value, I value and product value, the space is common. Memory is common, right? You take N value as 1000, it will store the same location only, na? In the same location only, na? Got it? These are all the big O notations. This is, see, Prakash, see, that's what I tell you in the starting of the topic of this one. I'll tell you more, I'll tell you more in-depth information about this time and space complexity in the further sessions. This is just a short form, so I'm telling you here. Got it? One thing is, what is this O of 1, O of N is actually saying, see, this is one metric. You should what you can say, you should follow this asymptotic notation to represent this time and space complexity, which is common for everyone. See, if you write this time and space complexity in one methodology, if I write it in one methodology, some other person will write it in another methodology, it leads to confusion. That's why the scientist has provided an asymptotic notation, where for that he is using the big O, big omega and big theta notations. Got it or not? Okay, so that is what this one. Okay, understand or not? Don't consider that language means not language. It is one language and the metric. That's what I'm telling you. Got it or not? It is, see, for representing this, what you can say, time and space complexities, they have provided a unique terminology. Got it or not? Unique metric they have provided for us. Got it? So we'll see more in-depth information about this in the tomorrow session, like when you will get this O of N square, O of log N, okay, O of N cube, O of 2 to the power of N, how you are going to use this big O notations, etc. and all. Okay, Everything we'll see it in the tomorrow session in depth clearly. Okay. I mean, if you use nested for loops, what happens? If you use multiple for loops, what happens? If you use only, in some situations, if conditional conditions and loops, we will use it. In that case, how you are getting the time and space complexity? Yes or no? No. We are just assuming like that, and we are taking Prakash. We are just assuming like that, and we are taking. Understand? That's what I'm telling you, Prakash. To understand this metric, okay. So I am assuming like that. The first thing I mentioned there, I am assuming like that, and then we are taking. Okay. So to find out the this time and space complexities, that's what I said you in the starting of the session itself. Okay, I am assuming like that. We'll discuss more in the tomorrow session, no problem, Prakash. Okay. Yeah. So that's all for the today's session. Okay. I hope you understood this session. Okay. We'll discuss more about this time and space complexities and what are the different things, how to achieve. Everything we'll see it in the tomorrow session. Okay. Thank you. And you people will get demo videos of yesterday and today's session to your registered mail IDs. Okay. Yeah. You didn't get reply from Vishwanath? Meghraj?
Yeah, I messaged him, but I didn't get any reply.
1 minute, Meghraj. I'll provide my number. You please ping your number to me so that I'll inform. I'll just forward your number to them. Okay.
Yes, sure. Thank you.
You please provide your number so that I'll inform to Vishwanath to make a call to you and to speak with you. Okay.
Yeah, sure. Yes, sounds good. Thank you.
Thank you. Okay. Yeah, that's all for the today's session. So we will meet in the tomorrow session at same time at 8 o'clock. Okay. When will we get today's notes? Okay, you will get it. This notes and all, right? I'll plan and I'll tell you. So generally we will share this entire notes to you people through WhatsApp, but that will be created after 5 days of a session. But I'll plan and I'll send you along with this copy and all.
Yeah, Bindu, and also you said you would be sharing the course content today.
Course content and all, yeah. So that's what you have you login into. I mean, have you login into that WhatsApp or this one Telegram group?
Yes,
okay.
yes.
Yeah, please. Yeah. Okay, I will send it. This image and as well as this notes and as well as that syllabus content and lead code problems and all. I'll send it to you. Yeah.
Thank you. Thank you.
Okay. Yeah. Once it is done, right, I'll inform to my admin so that he will send those documents also along with the demo videos to your registered mail IDs. That is fine actually. Okay.
Sure.
Yeah. Thank you so much. Bye-bye. Meet you in the tomorrow session at same time. Thank you.
Thank you. Bye all.
Bye. Thank you all. Bye.